G'day, Alucard J here. Before we finally get to test this Perlin module, I just wanted to make a couple more custom classes. See on our initial noise example, we have this function for returning a texture from a 2D array of floats. We also have this function here that will generate a gradient for us. And what I want to do is wrap these up in their own little script. Now, unlike the Perlin class, which has variables on it and properties, we'll create a static class. Now, sometimes you might see in a project a script called utils or helper, and it will be a static class. Now, this is kind of like the one-shot thing that I want to make here. It's static, so there's only one instance of it that exists, but it's not something that holds values and perpetuates through your project. It's just like a calculator sitting on the side. You just spit some values at it and it will return something immediately. Like, that's it. So let's create a utility script for the texture. I'm just going to call it utils texture. Now, as I said, this is going to be a static class, so we don't need to create an instance of it. It doesn't have to inherit mono behavior. It won't have all that stuff. It's a public static class. And just for starters, like I said, we're going to we're going to be using it to return our texture 2D. Let's just start with our grayscale. Get texture, a 2D array. We are using grayscale, so we'll take that away, we'll take that away. So again, this is a script you can carry from project to project. Anytime you want to create a 2D grayscale texture from a 2D array of floats, you simply call this class, call this function, and it will return a texture for you. Now that's going to throw an error, I know that. So let's see if I've got anything wrong here. Okay, fantastic. Now, again, because I make it up as I go along, let's see if we can do the same for the gradient. Now we have a couple of other functions happening here. I know we have to make them static. I don't know if it's going to create problems. So, public static gradient that goes, let's call it something else. Get terrain gradient. Now I'm pretty sure these need to be static too. May need to make them public, I'm not sure yet. Ah, okay, so we're almost there. Always forget to return it. Okay, so because they're on the same static instance, they don't need to be public to be called locally. That's good to know. Okay, so now finally we can test this Perlin module. Let's create a new script. Such a great naming convention. Let's put all this in a new scene. Get rid of that script. So what's going to happen in our Perlin module example? First of all, we're still going to need to assign some variables to our class. Let's get that. So we have our size. And yep, we'll need a renderer output too. So we have our size, a frequency, octaves. This will keep them in the order of the constructor. What did I do there? Okay, so when we start, we'll do the same thing. We'll assign that renderer to whatever the script's attached to. We don't assign it separately. Don't have a gradient declared yet. Let's just start with grayscale. Let's see if it works. I'm going to need a generate noise function. So what happens in generate noise? Create our array. We've got all that. So now we can create an instance of our Perlin module. We can assign it some variables, and we can give them to this texture. So let's start with a float array. No. Sorry. Now let's start by creating an instance of our Perlin module. New Perlin module, and we'll give it our size, which is our texture size. Give it our frequency. Give it our octaves. Give it our offset. Give it our lacunarity, and we'll give it our persistence. So we've used all the parameters. Okay, so now we generate our noise array, and our noise array will be our Perlin module get noise, public noise array equals Perlin module get noise map. Output renderer, and now we call our static class utils texture get texture of our noise array. Offset. We call it noise offset. Well, let's just call it offset now. Fantastic. Let's attach the script. As you see, because we have now a class that has a Perlin module that did all those calculations for, we have a much smaller script. Just have the variables that we're going to assign to the Perlin module. And we've got a static class that will generate the texture for us. Much cleaner. We hit play. We're back to our noise. Oh, let's not increase the octaves too much. Let's increase frequency. Exactly the same result, but in a much cleaner script. Alright, let's see if we can quickly implement the gradient as well. So in our texture utils, if we had the same method, but we also took in a parameter for a gradient. So we need that evaluate. Just going to cheat and copy it off here. Instead of constructing a new color, we're going to evaluate the color gradient we send to it. And get texture, noise array, and let's just even call the utils straight from it. Utils texture, get terrain gradient. Now it'll produce a color map. And there we go. And that's about it, as you can see. Now with a simple script, a Perlin module, and a couple of little helpers, we can generate our noise maps far more efficiently.